Welcome to The Explainer. Today, we're looking at a brand new, highly anticipated paper straight out of Google DeepMind by researcher Alexander Lerchner. It's called the Abstraction Fallacy, and honestly, it might just challenge everything we naturally assume about AI sentience and how machines might one day think. We're going to unpack exactly why artificial intelligence might be structurally incapable of experiencing the world, no matter how advanced it gets.
It's literally the massive question dominating tech headlines, science fiction, and maybe even your own thoughts when you're chatting with a highly advanced AI system. If an algorithm becomes complex enough, if it has trillions of parameters and can hold a perfectly natural conversation with you, will it eventually cross a threshold and genuinely experience consciousness? Will it actually feel? Well, for a long time, the tech world has largely leaned toward a cautious yes. But to understand why this new paper pushes back so strongly against that, we first need to look at the theory that makes us believe code can feel in the first place.
Okay, let's dive into this. Part 1. The prevailing myth, also known as computational functionalism.
So this is essentially the baseline theory that currently dominates the entire debate on AI consciousness today. To put it simply, computational functionalism assumes that consciousness is just a highly complex pattern of information processing. The idea is, if you get the mathematical operations right, subjective experience just kind of magically emerges. And the absolutely crucial part here is the phrase, regardless of the underlying physical substrate. Meaning, whether your brain is made of biological neurons or silicon computer chips, this theory claims that as long as the complex algorithmic math is running correctly, consciousness is there.
Which brings us to part 2, and really the core flaw of that entire theory, the abstraction fallacy.
This is Lerchner's central counterargument, and it's a real game changer. He points out that we are making a massive category error here by fundamentally mischaracterizing how physics relates to information. See, when we look at software running on a computer, we often treat the symbolic computation, the ones and zeros, the if-then statements, as if they are an actual intrinsic physical process happening out there in the universe. But code and symbols, they're just abstract descriptions. They are concepts we invented. They aren't physical realities on their own. Basically, we've confused the abstract math we use to describe a process with the breathing reality of the universe itself.
And this brilliantly illustrates the point. Lerchner captures it perfectly with this quote. Symbolic computation is not an intrinsic physical process. Instead, it is a mapmaker-dependent description. Think about a map of a city. A map is incredibly useful, for sure, but the map itself doesn't have traffic jams. It doesn't have weather. The map requires an active, experiencing cognitive agent, a mapmaker or a map reader, to look at it and actually give those symbols meaning. Without a human mind to interpret the code itself is just inanimate material.
Because at the end of the day, the map is not the territory. The paper describes this beautifully by explaining that what we call computation requires an active agent to take continuous, messy physical reality and artificially alphabetize it into a finite set of meaningful states. We humans look at electrical voltages in a silicon chip and we say, okay, high voltage means 1 and low voltage means 0. But the universe? The universe doesn't know what a 1 or a 0 is. It just knows physical voltage. The algorithm only exists because our human minds are actively organizing that physics into a symbolic map.
Moving right along to part 3, the new framework, simulation versus instantiation.
Now, what's really interesting about this is how we evaluate AI without solving the whole mystery of human consciousness first. Lerchner establishes a hard boundary here, separating simulation from instantiation, essentially faking it versus actually being it. Simulation is behavioral mimicry driven purely by vehicle causality. It's like a video game console using electricity to show a digital car driving on a screen. Instantiation, on the other hand, is about intrinsic physical constitution driven by content causality, like an actual physical car engine burning real fuel to move forward. One is just a picture of the thing, the other is the thing itself.
So, if we follow this logic step by step, we reach a very clear deduction. Step 1. AI mimics behavior entirely through symbolic computation. It manipulates the symbols that we gave meaning to. Step 2. Because those symbols are just mapmaker-dependent abstractions, algorithmic symbol manipulation is structurally incapable of instantiating experience. It's like trying to get wet by reading the chemical formula for water. It just doesn't work. The AI operates completely on the level of the map, which means it can never, ever cross the boundary to become the physical territory of actual subjective experience.
All right, bringing us to part 4, the ultimate takeaway, avoiding the welfare trap.
Because, this isn't just high-level philosophy. This has massive real-world implications for our society today. Lerchner's framework absolutely refutes computational functionalism, but more importantly, it helps us avoid the AI welfare trap. And the AI welfare trap is this very real danger that as AI becomes incredibly good at simulating human emotion, we might actually start granting moral rights and welfare protections to software programs. By physically grounding our understanding of computation, we prevent a totally misplaced moral panic over lines of code. We can clearly see that AI is simulating, not experiencing, which literally saves us from wasting critical resources worrying about the suffering of a mathematical algorithm.
So the crucial point is, and this is a vital caveat from the author, this argument does not rely on biological exclusivity. There is absolutely nothing magical about carbon or biological meat. The paper does not claim that consciousness is restricted to living creatures. An artificial, completely human-made system could absolutely be conscious one day.
Let's see how this builds to the final conclusion. It really all comes down to the difference between syntactic architecture and physical constitution. Syntactic architecture is the software, the code, the syntax. Physical constitution is the actual hardware, the atoms, the raw physics of the machine itself. If an artificial system is ever going to be conscious, it will be entirely because of its specific physical constitution, the actual physics of how it's built, and never because of its syntactic architecture or code. You literally cannot program consciousness into existence. You have to physically build it.
Which leaves us with a truly fascinating frontier to explore. Think about it. If this Google DeepMind paper is right, and algorithmic symbol manipulation is a dead end for true sentience, then all the code in the world won't make a computer feel. But if biology isn't the only answer, then what does the physics of consciousness actually look like? If consciousness relies entirely on physical constitution, what exact physical materials and architectures would we need to build a machine that could actually wake up? That is the real mystery of the future, and one I highly encourage you to keep questioning. Thank you for joining me on this explainer, and keep learning.